Welcome to our presentation on DKomplex Intelligent Machine Learning Forecast Model. Our project is developed by Nicole Alsaba, Chika Starks, Deborah Shaw, Joshua O'Carroll, and Daniel Arias. Our objective is to build a robust forecasting solution using Azure AutoML. Our approach is to identify top-performing models and feature sets and evaluate them with different metrics. The client needs a reliable and accurate forecasting solution to predict future sales based on historical data and external factors. The solution is to use Azure AutoML, Azure Lakehouse for model training and data storage, Python, Pandas, Scikit-learn for data preprocessing and metric computation. We use R-squared, mean absolute percentage error, mean absolute error, and root mean square error for model evaluation.
To our implementation strategy. We started by cleaning and standardizing over 10 years of data to prepare it for forecasting. We then created time-based features like lags and seasonal patterns, along with other indicators to improve predictions. Forecasting was done in Microsoft Fabric's AutoML time series module, which tested and compared multiple models. Results were validated through manual analysis, comparing short and long-term forecasts. Finally, we saved models, compiled metrics into reports, and shared them for review. Challenges that we faced in our project were data quality issues, which required extra cleaning before modeling. A learning curve with Microsoft Fabric slowed progress until tutorials and test runs got us up to speed. Only one AutoML run could be active at a time, so we coordinated schedules. For unfamiliar data fields, we used correlation analysis to find the most relevant features, and model testing in AutoML was time-consuming, so we created reports to highlight the best results.
What you'll see. Today's demo shows how we load a client or product series, select a forecast horizon, generate predictions with R-squared and MAPE, and export an NDA-safe Excel report. Open the notebook, select data, and horizon. We ran in Microsoft Fabric the notebook connected to Lakehouse, pulling 10 years of cleaned invoices plus key economic indicators. We focused on future orders, set a recent date range, picked a 3, 6, or 12-month horizon, and clicked Run Forecast. Behind the scenes, the pipeline built lag features, rolling averages, and leading indicators, called our AutoML via FLAML, and used time-based validation. Metric snapshot and forecast. We presented R-squared, MAPE, and future order values. The 3 to 6 month horizons were most reliable. 12-month was more variable and used directionally. Future order values for each model are graphed in the chart. What changed performance? Gains came mainly from filters such as outlier capping and date range. Feature choices gave better performance than model swaps for MAPE. Experiments were tracked in Elmo Flow. Constraints we solved. We worked around AutoML not supporting ARIMA in UI, single notebook compute limits, and data formatting. Why it matters. The results were actionable monthly forecasts, a reusable pipeline, and a solid foundation for future teams.
Conclusion and summary. In conclusion, we contributed significantly by adding 35 new datasets, 16 of which were approved, and engineering impactful features to improve forecasting accuracy. We tested these features across 1, 3, and 12 months horizons, defining multiple models and finding strong performance from extra trees. Working closely with the DKomplex team, we strengthened the base model and delivered a robust forecasting framework, well positioned for the next phase of development. Accomplishments. Our team gathered new data, performed feature engineering, and tested various forecasting models to enhance the DKomplex base model. We explored different prediction horizons, used AutoML to evaluate algorithms, and fine-tuned configurations with DKomplex guidance, achieving improved forecasting performance and detailed results.
Future work. We wanted our research to provide clear directions for developing the optimal PPU forecasting solution, with detailed performance insights to guide future development efforts. To facilitate the knowledge transfer for future students, we provided Excel reports with detailed insights and performance metrics. Microsoft Fabric notebooks with complete workflows, comprehensive documentation for future teams, and clear guidance on the most promising methodologies. This project provided valuable hands-on experience with enterprise-level machine learning tools such as Microsoft Fabric and Azure AutoML, as well as real-world forecasting challenges. Managing shared resources and coordinating team workflows in a cloud environment provided valuable experience for future industry work. Working with DKomplex's engineering team highlighted the importance of clear communication and iterative feedback in real-world projects. Most importantly, this experience bridged the gap between academic machine learning concepts and practical business applications, preparing us to adapt our theoretical knowledge for real-world client solutions.
I'd like to thank DKomplex for their ongoing guidance and support throughout this project. We're also grateful to our CST 499 instructors and mentors for their insight and feedback. Thanks to our audience, and questions are welcome anytime.